Good morning to all. Myself, Dr. Arun from Aerospace Engineering Department. Today, I am going to take one topic from fluid mechanics for aerospace subject. If the topic name is Introduction to Boundary Layer. So, in that things, what is meant by boundary layer? So, in that boundary layer, it is a thin layer of fluid near the solid surface where viscous force cause the fluid velocity to decrease from the zero at the surface to the free stream velocity. So in that boundary layer, it can be developed in that over the solid surfaces only. And these are all the boundary layer formations. So in that boundary layer formations, it can be formed in that following manner. First one is the no slip conditions. So here the fluid velocity is 0. Next one is a viscous effect. So in that viscous effect, if the boundary layer, it can be adjust the viscous during the flow of the fluid. Next one is a velocity profile. So in that velocity, it will be increases from the 0 at the surface of the free stream beyond. Next one is in that boundary layer can be classified into two types. Previously we discussed that, and that laminar boundary layer and turbulent boundary layer. So in that laminar, already we discussed in that previous video. So laminar, it is a streamline flow. Turbulent, it is a irregular manner flow. So in that laminar, we are using the certain number of Reynolds number. For turbulent flow, we are using a certain number of Reynolds number. So in that laminar boundary layer, the momentum transfer between the one medium to other medium is very, very low compared to turbulent boundary layer. And these are all the turbulent boundary layer region. So here there are high mixing of one flow to other flow has been conducted. So in that layer thickness, the boundary layer thickness, it can be classified into three types. So first one is first, what is meant by boundary layer thickness? So the distance from the surface where the fluid velocity reaches approximately 99 of the free stream velocity. That is called as a boundary layer thickness. So it can be classified into three types. First one is displacement thickness, momentum thickness, energy thickness. In that boundary layer thickness, if the symbol is a del, so it can be vary from one region to other region. So you see that the figure. So here the free stream velocity, it will be found in that region. And next one is the displacement thickness. It will be denoted as del star. So the definition of the displacement thickness is the theoretical measures to how much of outer flow is displaced due to reduced velocity inside the boundary layer. So here it is the distance surface would have moved outward to proceed in the same flow as the actual flow within the boundary layer. So the purpose of the displacement thickness is it is used to calculate the changes, the drag and pressure distribution in that regions. And the next one is the momentum thickness. So in that momentum thickness, it can be noted as theta. So here the purpose to this momentum thickness, it is calculating the drag exponent by an object as it is related to the momentum loss due to the skin friction drag. This is called as a momentum thickness. So in that momentum thickness, the definition is thickness of the boundary layer with free stream velocity carrying the boundary layer moment. And the last one is the energy thickness. So in that energy thickness, it can be denoted as say a delta E. So in that energy thickness, the definition is relationship between the reduction in kinetic energy within the boundary layer and compared to the free stream flow. So if the purpose is, it is useful to quantify the energy dissipation within the boundary layer itself. So these are all the boundary layer thickness. It can be calculated by using some formulas. So the formulas it will be derived in that class itself. So the significance of boundary layer thickness, for example, we will calculate the following thickness. Following things. First one is a drag estimation. Second one is a flow separation. And the next one is a pressure effects. And the last one is a heat transfer. So in that heat transfer, they are calculating the thermal energy loss in that flow. So thank you. We will catch you on next topic on next series.